Hello guys, welcome back to the channel Campus Coders. Today we will see some questions on binary search. We will first see what binary search is and we will see some questions on binary search on arrays. Okay, so what is binary search? It's an algorithm to use to search an element in a sorted array. So this binary search works only if the array is sorted. Okay, so this works something similar like finding a word in a dictionary. Let's say we are going to find the element 7. Okay, in this array we need to find the index position at which this element presents in this array. So what we will do is we will check if this element present in the left half of the array or right half of the array. Okay, so to find the halves of the array, what we need is the mid index, right? To get the mid index, we need start index and then end index. So what we will do is we will initialize two pointers, one in the start of the array and one in the end of the array. Those will be start and end pointers, and the mid pointer will be calculated by average of these two. That will be 0 plus 1 2 3 4 5 6 6 by 2 3 0 1 2 3. So this will be the mid pointer, right? So if this is mid pointer, and we will check the element in the mid pointer 4, that is less than the target which is needed. So what we can uh, conclude from this is it doesn't lie in the left half of the array. So we are just going to ignore this part of the array. So what we will do is we will change the start pointer to mid plus 1. Okay, so we will say this as start now. Okay, and then we will calculate the mid again from with this will be the mid, and again we will check if this mid how it is related to this mid element. Now if this mid element is equal to the target in the value, so we can say m will be the index of the target element. So this way we can say. Similar way, if let's say we are finding an element, and then if it is in the left half of the array, what we will do is we will change the end pointer to mid minus 1, right? Because it is not, since it's not going to be in the right part of the array, it will always be in the left part of the array. So it will be, when this is m, we are going to check in the left part of the array. So this e will be cancelled and it will come here. So if this is e, then e will be mid minus 1. Now we will see the algorithm of this code. You can understand from that. We'll first initialize start array, start pointer, and then end pointer at 0 and size mason 1, and then we are finding the mid value. You can just even write s plus e by 2 as well, but here this is more better approach, because let's say if the array is so long and then s and e will be so high, so when we are adding s plus e by 2, it may go beyond the range of int data type. So what we do is start plus n minus 2 n minus start by 2. This is equal to s plus e by 2. Just we will do in this format, so that the output will be in int range. So we are doing like this, and we are going to loop this until and unless start doesn't exceed n pointers value. So we are going to have while start is less than n, we are going to check if this mid element is equal to the target. If it is so, we are going to return the mid element. Or if the mid element is less than the target, we are going to increment the start value to mid plus 1. Or if the target is less than the mid element, we are going to decrement the end pointer, and then in every loop we are going to change the mid value every time. So we are again writing the statement, we are modifying this mid value one every time, and then if there is no mid element, we are going to return minus 1. This is the approach. This can be done in recursive method as well. The code is here, you can just check it out. It's just the same what we are going to do. Instead of having a while loop, we are just going to have a base case here. When low is greater than high, that means when this start pointer exceeds end pointer, we are just going to return minus 1 there. And then we are going to have a mid value that's changing every time. and then we are going to have the three cases, possible cases, and what we are going to do in each cases. We are going to change the parameters, like when key is greater than mid, we are going to change the start parameter to mid plus one. If the target is less than mid element, we are going to change the end pointer to mid minus one. That's it. So this is how the binary search works. Okay, let's start with some questions. So first one is to find lower bound and upper bound of an element in an array. And obviously the array will be sorted here because binary search will be used only in the sorted arrays. So given an array and an element, we need to find first the lower bound of that element. Let's say if the element is 2 here, we need to find the smallest index such that ARR of that index is greater than or equal to that target element. Here, the target element is 2. The lowest index such that the element is greater than or equal to 2 is index 1, right? Because it is equal to 2. So that one we need to find. Same way, we just like how we are using binary search, we are going to do. We are going to have a start pointer and then end pointer and then a mid as well, obviously. And then what we are going to do is while low is less than high, we are going to change the mid element in every uh, loop. And then when the mid element is greater than or equal to x, okay, let's just a minute. First we will have a start, and then we'll have an end, and then the mid will be obviously this one here. So if this mid element is equal to this target, what we're going to do is we will first uh, say this as the answer. Okay, we will set this as the answer, and we will check. We will have the end pointer as, that means the high pointer as mid minus one. Okay, end pointer will be mid minus 1. This is because we need to find the lowest index, right? So what we are going to do is we are going to check. We will first see if that is equal to that current target or not. If it is equal to target, we are going to check if there exists any other element that's in the left part of that array. If that is going to satisfy or not, we are going to check the leftmost possible answer, right? So we are going to have e equal to m minus 1 here, right? If it is greater than equal to x, okay, if it is equal or if it is greater, whatever it is, we are going to do this. If it is not so, if it is less than, then it's obviously in the right side part of the array, so we are going to increment the lower pointer, that means start pointer, to mid plus 1. This, so we are going to find the lower bound of the element. The similar way, if they are asked us to find the upper bound, it's we are going to see the rightmost part of the array. So what we are going to do, same start element and start pointer and pointer we are going to have. When low is less than equal to high, we are going to modify the mid element every time. And if the the element in the mid pointer is greater than the index, then it's obviously the answer will be somewhere lying somewhere in the left part of the array. So what we're going to do is, again we are going to initialize answer as mid and then decrement the high pointer to mid minus 1. Else what we are going to do is increment the low pointer to mid plus 1. It's the same, but the thing is, here we will consider if it is equal to or as well, but here we are not going to consider. That's it, the difference between lower bound and upper bound. um, let's go to the next question as well. Finding floor and ceiling of an element. Okay, given an array like this and an element 5, so we need to find the highest element less than 5 and lowest element greater than 5. So here it will be 4 and 7. That one we are going to find. First we will find the floor element. For the same we will do. We will have a start pointer and end pointer. We will find the mid of these two. Mid will be here. We will check if the mid is less than equal to the target element. If it is so, we are going to increment the low pointer to mid plus 1. And then for now, here we are going to have answer is equal to this mid element. Okay, answer is equal to mid element, and we are going to increment the mid pointer to start pointer to mid plus 1. Okay. Yeah. And then if it is not so, uh, then we are going to decrement the high pointer to mid minus 1. That's it. This is for finding floor. If we are going to find the seal, the same we are going to do. But thing is, if here is great, the mid element is greater than equal to x, then we are going to store the element. Here we are storing the element only if it is less than equal to x. We are going to store if it is greater than equal to x, because if it is less than equal to x, we obviously know that it's not going to lie anywhere in the left part of the array. We need to find in the right side part of the array if there exists any other element that is greater than the mid element that we found now, and then less than the target element which they are given. So we need to find the right side part of the array. Here we are going to check only the left side part of the array, because once the element is greater than equal to x, then it obviously there it will exist in the left part of the array. So for now we will have it in the answer, and then you will decrement the high pointer. That's finding the C. To find the first and last occurrence of a given element, let's say this as the given array and they have given an element 13. We need to find the first occurrence and last occurrence of that element 13. So here element, first occurrence will be the index 2, last occurrence will be index 4, right? That two index we need to written. Okay, so this is also given a sorted array. So whenever it's sorted array, then obviously it will be somewhere related to binary search. So in by for finding first occurrence, what we will do is we will do the same start pointer, end pointer, and we will have a mid. And then since we are going to find the first occurrence, we need to find the leftmost possible answer. So what we are going to do is first, whenever if the mid element is equal to key, we are going to have it inside the answer. Okay, we are going to initialize, we need to initialize there itself, and then we are going to get the midpoint end pointer to mid minus 1. Okay, and if key is greater than mid element, then then it means that the array is in the right side part of the array. So we are going to increment the start pointer to mid plus 1, else mid minus 1. That's it. Okay, the same way we are going to do for last occurrence. Since in last occurrence we need to find the rightmost part of the answer. The same way, whenever we are finding an array in the mid element is equal to the target, we are going to initialize it, and then we are going to take the start pointer to mid plus 1. Okay, because we need to find the rightmost part. So we are dealing with the left part of the array. We are taking start is equal to mid plus 1. Then the same part. If the target is greater than mid, we are going to get s is equal to mid plus 1, else e is equal to mid minus 1. That's it. The same part. If they ask like they find the count of an element, then the same we can do. We can find the first occurrence, last occurrence, and then we can just subtract these two. We will get the count of the element. Subtract it means last element, last occurrence minus first occurrence plus 1, because it's zero based index. So we are going to do this. This will give us count of the element. Okay, so by this way we can do this type of questions. So next question is to find the minimum element in the rotated sorted array. So there will be a given array which is rotated by some number which is not given, and it is the array is actually sorted and then rotated. We need to find the minimum element. So the minimum element can be found by just sorting the array and finding the first element. That would be the easiest way. But there is another way to do this using binary search as well. So let's say if you are plotting this array in a graph, it would be something roughly like this, right? Like this. Okay, it will be just around roughly like this one. So we need to find this element here, which is the minimum element, right? So there are, let's say, all the possible chances of location of start and then end pointers. Okay, so let's say the start pointer and then end pointer lies here within this part of the array. So it's just the normal array. It means the array is already sorted. So the minimum element in this part of subarray would be the start pointer itself, right? Similarly, if the start element and then the end pointer would be here, so it means the same case we can say that the minimum element is the start pointer itself. So this is one of the edge cases, right? So let's see what other cases can be possible. Let's say the start pointer is here and end pointer is here somewhere in this array. Okay, so we need to find the mid pointer. There is chance that the mid pointer can be here or else here. So if the mid pointer is here, okay, the mid pointer is here, it means it is greater than the lower element, right? It's greater than the element in the lower index. So it means the minimum element would be the lower element itself. And then we are going, it's not going, the minimum element doesn't, there is no chance that the minimum element will be in the left part of the array, so we are incrementing the lower pointer to mid plus 1. Okay, so this is in case if the mid pointer is present in this part of array. If the mid pointer is present in this part of array, then it means the uh, answer can be, answer will be, for now it will be the minimum of the previous answer, and then this mid element, because this is great lesser than the highest pointer, right? So we can say that, and then it's not going to be in the right side part of the array. So what we are going to do is we are going to reduce the highest pointer to mid minus 1. Okay, so in this way we can say, let's see the code here once. So we are, as usual, we are going to take the low pointer, high pointer, and we are going to update the mid element every recursion, every loop. Okay, so this is the edge case which we have seen at first. If it is already sorted, if the search space is already sorted, we are going to find the minimum element, minimum of that, and then we are going to break from the loop. And then this is the first case, if the mid element is present in this part of the array. Okay, if it is present in this part of the array, we are going to increment the lower pointer. Or else if the minimum mid element is present in this part of the array, then we are going to decrement the highest pointer, and then we are going to proceed with this loop. So this is the solution for finding the minimum element in the rotated sorted array. This question can be also asked in other way, like how many times the array has been rotated. Okay, so if it's equal to the minimum element, because let's say this will return value of this one index, right? It means like it's rotated 1 2 3 4 times, so the answer would be similar to the minimum element of the rotated sort array. So both questions have the similar answer. So yeah. So next question, we need to find the nth root of a number m. Okay, so let's say they give a number m is equal to 8, and then n is equal to 3. Okay, we need to find cube root of 3. Cube root of 3 would be 2, right? So we need to find this part. So what can be done for this is, one possible way is to use normal loops and then find this out. Other way is to use binary search. So as we know, like for binary search we need a sorted array, right? So here what can be the sorted array? If we observe, for to find the nth root of a number m, so nth root of number m always lies within the range 1 to that m, right? So 1 to m is itself a sorted array. So we can say, we can take this as the sorted array and find which is the possible answer, okay? So we will usually take this as low pointer, this as high pointer, then we will update the mid value every time, and then we need to find the if that mid value is the nth root or not, right? So what we are doing is we are for calling a function. Okay, so what we are doing in this function is we are going to run a loop and then multiply the answer from 0 till n. Okay, so during this loop, whenever if all the answer is greater than the required m value, okay, then we are going to return a number which we will use it for finding the each cases. Okay, there will be three cases possible. If the answer is greater than the m, the required number, or if it is equal to m, or if it is less than m. Okay, so if it is greater than m, we are going to return 2. If it is equal to m, we are going to return 1. If it is less than m, we are going to return 0. Okay, so, and then we are going to check each of these test cases in our parent function. If it is equal to 1, then the mid value itself is the required nth root. So we are returning that. If it is equal to 0, then it means there exists some point, the value of n that is greater than the mid element, right? So we are incrementing the low pointer to mid plus 1. If the answer is greater than the required value m, then we need to check in the previous values, right? So we are going to reduce the high pointer to mid minus 1. So this is how we do the nth root of m type of difference. That's it for today's video. I hope you have learned a lot of things in this video. The links to the questions will be given in the description below. You can definitely check it out and practice them. You can follow me in LinkedIn and Instagram. The link will be given in the description below. So yeah, I will meet you in the next video. Until then, keep coding. Bye bye.